The story of Albert Einstein begins not with laboratories or theories, but with a quiet child sitting alone, lost in thought. In the small German town of Ulm, in 1879, a baby was born who would one day change the face of science and alter how humanity perceives the universe. Yet, in those first years, nothing about young Albert suggested he would become the greatest mind of the modern age. He was slow to speak, often silent for long periods, and his parents worried that something might be wrong with him. But behind that silence, something extraordinary was forming, a deep, boundless curiosity about the world around him. Einstein's early years were filled with questions that no one could answer. Why did a compass needle always point north, even when turned or moved? What invisible power guided it? To most people, it was a simple fact of nature. To young Albert, it was a mystery that burned like a spark in his imagination. This single experience, a small compass his father gave him, opened his mind to the invisible forces of the universe. It made him realize that reality was far more mysterious than what the eyes could see. That sense of wonder became the pulse of his life. But Einstein's curiosity did not always fit inside the walls of his classroom. The late 19th century was a time when schools demanded obedience, memorization, and discipline. Students were expected to repeat, not to question. Teachers wanted silence and conformity, not imagination. Albert, however, refused to accept ideas simply because they were taught. He wanted to understand why things were true. This constant questioning often made him a misfit. His teachers saw him as lazy, disobedient, even rebellious, a student unwilling to follow rules. Yet, in truth, he was not rebelling against education, he was rebelling against limitation. In one famous incident, a teacher told him bluntly that he would never amount to anything. Another said his mere presence undermined the respect of the classroom. To them, he was a troublemaker. To history, he was a thinker far ahead of his time. In a world built on authority, Einstein believed in the freedom to think differently. That belief became both his greatest challenge and his greatest strength. At home, his parents, Hermann and Pauline Einstein, nurtured his growing fascination with science. His father, an engineer and small businessman, introduced him to simple electrical devices, magnets, and light currents. His mother, a pianist, filled the home with music, shaping in him a love for harmony and creativity. Albert often said later in life that music, especially Mozart, helped him think. He didn't just play notes, he visualized sound as patterns and forms, a mental skill that mirrored how he would later imagine space and time. Even as a child, Einstein preferred thought experiments over toys. He would sit for hours, imagining himself riding alongside a beam of light. What would it look like? Would the light stand still? Could one ever catch it? These thoughts were the early seeds of relativity, planted decades before the world would recognize their importance. While other children memorized facts, Einstein explored the edges of reality within his own mind. Yet his early education nearly crushed this imagination. The rigid structure of the German school system stifled him. Teachers demanded answers, Einstein offered questions. When told to recite Latin or memorize definitions, he drifted into daydreams about invisible forces and unseen dimensions. His slow method of thinking was misunderstood as lack of intelligence. In truth, he was thinking more deeply than his instructors could imagine. He often said later, "It is a miracle that curiosity survives formal education." For him, the real miracle was that his own curiosity had survived at all. When Einstein's family faced financial troubles, they moved to Italy, leaving Albert behind in Munich to finish school. The loneliness and pressure of those months weighed heavily on him. He began to feel trapped, both by the classroom and by the system itself. At 16, he made a bold decision to walk away from school entirely. It was not an act of failure, but one of defiance and self-belief. He left without a diploma, driven by the conviction that learning should not be confined by walls or tests. He sought freedom, the freedom to explore truth on his own terms. After leaving school, Einstein joined his family in Italy and continued studying independently. He devoured books on mathematics, philosophy, and physics. He read the works of Newton, Maxwell, and Kant, not as lessons to memorize, but as ideas to question. He began to build a private universe of thought. His mind was not shaped by professors, but by curiosity itself. It was during these years of self-study that Einstein learned to think differently, not linearly, but visually. He imagined, visualized, and reasoned through intuition rather than formulas. In 1896 he enrolled at the Swiss Federal Polytechnic in Zurich, one of the few schools in Europe that valued creative thinking. Yet even there, Einstein's independence made him stand out. He often skipped lectures, preferring to learn through his own experiments and reflections. He respected few teachers, especially those who clung too tightly to old ideas. His professors grew frustrated with his questioning nature. One of them even refused to write him a recommendation letter after graduation. And so, once again, the young genius found himself standing outside the system, unrecognized and unemployed. But Einstein never saw education as a race for grades or approval. He once said, "I never teach my pupils. I only attempt to provide the conditions in which they can learn." This idea was born from his own struggle, the pain of being misunderstood by an educational system that valued obedience over curiosity. He believed true education was not about memorizing facts, but about nurturing the ability to think freely. During his early 20s, Einstein's passion for learning reached a new level of depth. Working as a clerk in the Swiss patent office, he spent his days examining technical designs, engines, electrical circuits, and mechanical devices. Though the job seemed dull, it gave him something priceless: time to think. Surrounded by inventions and blueprints, he began to imagine the universe itself as one vast, interconnected design. Each evening after work, he returned home to his notebooks, filling them with equations, questions, and dreams. In those quiet nights, the same curiosity that had once made him a misfit now became his greatest strength. He began to piece together the mysteries that had haunted him since childhood. The nature of light, the flow of time, the fabric of space. He realized that the key to understanding the cosmos lay not in what could be seen, but in what could be imagined. Einstein's journey from a misunderstood student to a visionary thinker was not an easy one. It was filled with rejection, loneliness, and self-doubt. Yet every obstacle only strengthened his belief that true discovery comes from independent thought. He had seen the flaws of a rigid education system and turned away from it, not out of arrogance, but out of faith in his own curiosity. The young Einstein learned one of life's greatest lessons, that imagination, when guided by discipline and courage, can outshine all traditional learning. His struggle with education was the crucible in which his genius was forged. Without that struggle, there might never have been the theory of relativity, the equation Ipmc-Dow's, or the revolution that followed. His early life teaches us something profound about human potential, that greatness often begins with questioning, not conformity. The world tried to mold Einstein into what it believed a student should be. Instead, he became what the world needed: a thinker who saw beyond the horizon of his time. Even as a young man, Einstein's mind was already reaching toward the unseen. The child who had once stared at a compass was now beginning to understand the forces that governed the stars. His journey through the rigid walls of education had not broken him, it had built him. It had taught him to trust his imagination, to follow questions wherever they led, and to never let the fear of failure silence the pursuit of truth. By the time Einstein began formulating his earliest scientific ideas, he was no longer just a curious boy. He was a mind that had broken free from all boundaries. And in that freedom, the world would soon witness the birth of a revolution in thought that would forever change our understanding of reality itself. In the quiet spaces of his youth, between frustration and wonder, between rejection and discovery, the foundations of genius were laid. Einstein's early curiosity, misunderstood and underestimated, became the seed from which the modern universe of science would grow. He had faced a world that demanded answers, and responded with deeper questions. And through those questions, humanity found a new way to see the cosmos, to understand time, and to imagine the future. The path that young Albert Einstein walked after his early education was one of quiet defiance and relentless inner search. Though the world around him saw only an ordinary young man, inside him grew the rhythm of questions that would someday shake the universe. His childhood had taught him that truth could not be memorized, it had to be discovered. His school years had shown him that authority could silence curiosity, but never destroy it. Now, as he entered adulthood, that same curiosity became both his compass and his rebellion, guiding him toward a destiny that neither teachers nor textbooks could have predicted. Einstein's life during those early years in Switzerland was a mixture of solitude and determination. His peers sought careers, titles, and security. He sought understanding. The failure to obtain a teaching post after graduation might have crushed another spirit, but for Einstein it was only another lesson that institutions were not the gatekeepers of genius. When he finally secured work at the Swiss Patent Office in Bern, it was not prestige that drew him there, but peace. Amid the hum of machinery and the shuffle of papers, he found a sanctuary for thought. Each patent that crossed his desk, inventions of electrical circuits, motor designs, communication systems, became a window into the mechanical imagination of humankind. And as he analyzed those inventions, another pattern began forming in his mind. A recognition that beneath every practical machine lay deeper laws of motion, energy, and balance. He saw beauty in the symmetry of function, a harmony between idea and structure. This harmony reminded him of music, the melodies his mother once played on the piano. In later life, Einstein would say, "If I were not a physicist, I would probably be a musician." For him, thinking itself was a form of music, an improvisation across the scales of nature. But behind the calm of his routine, there still lingered memories of the classroom that had tried to contain him. Einstein often spoke of how stifling it felt to be told what to think instead of being allowed to wonder. He understood that the world's greatest obstacle to progress was not ignorance, but the illusion of knowledge. Those who believed they already understood everything stopped looking for the unknown. It was this realization that separated him from his time. His teachers had taught from certainty. Einstein learned from doubt. Doubt, for him, was not weakness. It was the beginning of discovery. In the evenings after work, while others rested, he filled his notebooks with equations and thought experiments. His small apartment became both a laboratory and a universe. He imagined trains moving near the speed of light, clocks ticking differently for travelers and observers, and beams of light chasing through endless space. These were not the exercises of a student, but the meditations of a visionary. The boy who once stared at a compass now gazed into infinity. And yet, even as he wandered these vast mental landscapes, Einstein never forgot the loneliness of being misunderstood. That loneliness became part of his creative process. It gave him empathy, a quiet understanding of what it meant to question a world that resisted change. He would later encourage young thinkers to embrace solitude, to think for themselves even when others doubted them. He had lived that struggle. He knew its pain and its reward. Einstein's early rebellion against rigid education eventually shaped his philosophy of learning. He came to see curiosity as a sacred force, fragile, easily damaged by conformity, but capable of reshaping civilizations when protected. He often said that the key to his success was not talent, but passion for inquiry. "I have no special talents," he once wrote. "I am only passionately curious." To him, the act of wondering was holy, the essence of being human. Through his struggles, Einstein also learned compassion. He saw how many brilliant minds were lost in systems that valued obedience over imagination. He believed that true education should awaken joy in creative expression and knowledge. To memorize without feeling, he said, was to kill the spirit of learning. This belief would later influence educational reforms around the world, inspiring generations to rethink how knowledge should be shared. As Einstein's thinking matured, so did his sense of destiny. He began to understand that his rejection of traditional learning was not merely a personal rebellion. It was part of a greater evolution in human thought. Every age needs someone to break its boundaries. For the 19th century, imprisoned by classical physics and narrow education, Einstein would become that liberator. His early experiences, the punishment for questioning, the exile from schools, the endless solitude, all prepared him for the moment when he would have to challenge not a teacher, but the entire foundation of science itself. The scenes of his youth replayed in his memory, the teacher who mocked him, the lectures he ignored, the exams he refused to take seriously. What had once felt like failure now appeared as fate. Had he been a model student, obedient and unquestioning, he might have followed the established path of academic respectability. But the world would have lost the thinker who dared to imagine time itself as flexible. His struggles had purified his intellect, teaching him that truth is often hidden behind the fear of being wrong. By 1905, the year history would later call his annus mirabilis, or miracle year, Einstein had reached a quiet mastery of his own method. Without the support of a university or the guidance of mentors, he produced 4 groundbreaking papers that transformed physics. These papers revealed the structure of light, the motion of atoms, the equivalence of energy and mass, and the relativity of time and space. Each of them carried the same signature that marked his youth: the courage to question what everyone else accepted as true. And yet, beneath these triumphs lay the same spirit that had once resisted a teacher's command. The universe had become his classroom, and experience his textbook. He had turned curiosity into a discipline, imagination into mathematics, and solitude into enlightenment. Einstein's story shows that struggle is not the enemy of genius. It is its foundation. His battles with education were not accidents, but essential tests of his conviction. Through them, he learned to trust the quiet voice of intuition over the loud commands of authority. He learned that knowledge without freedom is empty, and that true learning begins only when one dares to think alone. The child who refused to memorize Latin verbs became the man who rewrote the laws of physics. The student who questioned every rule became the scientist who revealed that even time and space themselves were not fixed rules, but relative realities. His early defiance of rigid schooling mirrored his later defiance of the cosmic order. In both, he replaced obedience with wonder and repetition with revelation. Even decades later, when he had become a global icon, Einstein spoke fondly of his days of struggle. He would smile and say that those who understood him least had given him his greatest gift: independence. That independence of thought became the heartbeat of his life. It allowed him to see what others could not, that light could bend, time could stretch, and the universe itself was a grand symphony of energy and motion. In the broader story of human progress, Einstein's early years remind us that every era produces children like him, dreamers whose questions do not fit the test papers, thinkers who look beyond the curriculum. Too often, their curiosity is dismissed as distraction, their imagination as defiance, but within them lies the spark of transformation. Einstein's life is proof that when curiosity survives conformity, humanity moves forward. The genius who saw the future did not see it through telescopes or machines, but through the lens of a liberated mind. His education failed to teach him the answers, but it taught him the cost of conformity. And that lesson was enough. From then on, he chose a different kind of school, the school of the universe itself, where the laws of nature were his teachers and the stars his classroom. As we look back on that young boy staring at his compass, we realize that his journey was not about rebellion for its own sake. It was about faith. Faith that the universe is understandable, that reason and imagination can work together to uncover its secrets. His struggles were the necessary storms before the dawn of revelation. In a way, Einstein's early life mirrors the story of humanity itself, our endless quest to know, our frustration with limits, our longing for freedom. The institutions that once tried to contain him represented the same barriers that all civilizations must overcome: the fear of the unknown, the comfort of tradition, the reluctance to change. Einstein's triumph was not just scientific but symbolic. He proved that the act of questioning is the most powerful force in existence. By the end of his early journey, Einstein had already begun to see glimpses of the future he would later reveal to the world. A future where energy and matter were one, where gravity curved space, where imagination could predict the motion of galaxies. His struggles with traditional education were not detours, they were the crucible that prepared his mind to see such wonders. And so, when we speak of Albert Einstein, we are not merely speaking of a scientist who solved equations. We are speaking of a child who refused to stop wondering, a student who refused to stop asking, a thinker who refused to stop dreaming. His curiosity was a rebellion, his struggle a symphony, and his education, though broken and incomplete, was the foundation upon which modern science stands. Einstein's journey reminds every seeker of knowledge that the path to understanding is rarely smooth. It is filled with resistance, misunderstanding, and loneliness. But those who endure, who keep asking and imagining despite rejection, become the architects of new worlds. The genius who saw the future saw it, because he had once dared to question the present. And in that quiet defiance, in that young boy's refusal to let curiosity die, the universe found its voice. There are moments in human history when a single mind sees what no one else can, a flash of understanding that rewrites the story of existence itself. For centuries, humanity believed it had already uncovered the secrets of space and time. The universe, as described by Isaac Newton, was a grand machine, predictable, logical, and absolute. Space was the fixed stage upon which the stars moved. Time ticked uniformly for everyone, everywhere. It was a universe of certainty, a cosmic clock wound up by God and running forever according to precise mathematical laws. But in the quiet years of the early 20th century, in a small apartment in Bern, Switzerland, a young patent clerk named Albert Einstein began to hear a different rhythm of the universe, one that no one else could hear. While others saw time and space as rigid and separate, Einstein began to sense that they were woven together, flexible and alive. What the world saw as constant, he saw as relative. What the world believed to be fixed, he imagined as flowing. It began not with experiments, but with imagination. For Einstein, thought itself was the greatest laboratory. His mind became a theater where he could conduct impossible experiments. Experiments that defied the technology of his era. One of his most famous thought experiments began with a simple question: what would it feel like to ride on a beam of light? He imagined himself traveling alongside that light wave, moving at its speed, staring into its motion. Would the wave appear frozen, still in front of him? Would it remain a moving ripple of energy? The more he pondered this, the more he realized that the laws of physics must look the same no matter how fast you move. Even if you were chasing light itself, this single insight became the seed of a revolution. It told him that there could be no special observer in the universe, no absolute frame of reference. Everything, motion, time, distance, depended on perspective. It was as if reality itself shifted depending on how you looked at it. The idea was shocking. For more than 200 years, Newton's laws had ruled science, explaining everything from falling apples to the orbits of planets. To challenge them was unthinkable. Yet Einstein, working alone and without institutional support, dared to imagine that time and space were not separate entities, but parts of a single cosmic fabric. In 1905, while still working at the Patent Office, Einstein published his theory of special relativity. It was a theory born not in a laboratory, but in pure thought, an act of imagination so radical that even scientists struggled to believe it. The theory declared that the laws of physics are the same for all observers moving at constant speed, and that the speed of light is the ultimate cosmic limit, the one thing in the universe that never changes. But to preserve this constancy, something else had to give. That something was our most sacred belief, time itself. Einstein's equations revealed that time does not flow equally for everyone. It bends and stretches depending on motion. A moving clock runs slower than one at rest. Distance shrinks, mass increases, and simultaneity. The idea that two events happen at the same time becomes an illusion. The universe, it seemed, was not a fixed stage but a living, dynamic interplay between time, space, and motion. Reality was relative. At first, few understood what Einstein had done. His paper was elegant but abstract. It seemed more like philosophy than science. Yet those who read it carefully realized it changed everything. Suddenly, ancient questions about the nature of reality gained new meaning. Was there truly an absolute now? Could two observers disagree on the order of events and both be correct? The answers Einstein gave were yes, and it shook the foundations of physics. For Einstein, relativity was not just about equations, it was about perception. It was a new way to see the universe, a recognition that what we experience as now is merely a point of view, and that the cosmos has no universal present. Every observer carries their own clock, their own version of time. It was as if Einstein had peeled back the veil of reality and shown that truth itself was more flexible than anyone had imagined. But Einstein's thinking did not stop there. The success of his theory inspired a deeper question: if motion affects time, what about gravity? Could the force that holds planets in orbit also bend time itself? For years, Einstein wrestled with this question. He knew that Newton's law of gravity described how masses attract one another, but it did not explain why. It treated gravity as an invisible force acting across space. But what if, Einstein wondered, gravity wasn't a force at all? What if it was the shape of space itself? To explore this, he needed to imagine again, to visualize the universe not as emptiness, but as a flexible fabric that could bend and stretch under the weight of stars and planets. He imagined a giant cosmic sheet, warped by mass. A planet moving through this curved space would follow the lines of the curvature, not because it was pulled by a force, but because space itself was guiding its path. It was an entirely new vision of the cosmos, geometry as gravity, curvature as motion. This vision would later lead him to his next great creation, the general theory of relativity. But even in these early years, the seeds were forming. Einstein began to see time and space as inseparable dimensions of one grand entity, space-time. It was no longer possible to speak of time without speaking of space, or of motion without speaking of geometry. The universe was not a collection of objects moving through emptiness, it was a continuous, four-dimensional fabric in which everything, from particles to galaxies, was connected. What made Einstein's thinking revolutionary was not just his mathematical genius, but his refusal to accept what others called obvious. He questioned the unquestionable. He challenged the sacred assumptions that the universe was static, that time was absolute, and that space was passive. He dared to imagine that the cosmic laws might be written in a different language, one that united motion, light, and gravity in a single symphony of relativity. For Einstein, every breakthrough began with a picture in his mind. He didn't see numbers, he saw motion, energy, and the flow of time as living images. His imagination was not childish fantasy. It was disciplined vision. He once said, "Imagination is everything. It is the preview of life's coming attractions." To him, imagination was not the opposite of knowledge. It was the bridge to truth. His ability to visualize what could not be seen made him the first human to truly perceive the structure of the universe as it is, not as it appears. The world he unveiled was strange and beautiful. In Einstein's universe, time could slow down and even stop near the speed of light. A clock aboard a fast, moving spaceship would tick more slowly than one on Earth. A beam of light would curve around massive stars, bending not because of a force, but because space itself was curved. Even mass and energy were no longer separate. They were two forms of the same essence, connected by his simple yet profound equation, E tum isi dal. This single equation captured the unity of the cosmos. It meant that matter could be turned into energy, and energy into matter. It explained the power of the sun, the fire of the stars, and the potential within every atom. With it, Einstein had rewritten the story of creation. But when he first presented these ideas, many scientists resisted. The world was not ready for such a shift. The mathematics was complex, the implications enormous. How could time, the most familiar aspect of existence, behave differently for two people in motion? How could the universe itself be flexible? For centuries, certainty had been science's foundation. Einstein replaced it with relativity. Not chaos, but a deeper order, one that acknowledged the perspective of every observer. As his theories spread, the world began to see the depth of what he had done. He had not simply described the universe, he had changed the lens through which humanity viewed it. Time and space, once seen as separate threads, were now seen as one tapestry. Motion and energy, once distinct, were now united. Einstein's thinking was not an extension of Newton's. It was a transformation, a new chapter in the story of understanding reality itself. Even Einstein himself was humbled by the scope of his discovery. He often said he did not set out to become famous or to overturn physics. He was simply following a question wherever it led. That question, how does light behave, led him to a truth that transcended science. It revealed that the universe is not a collection of fixed things, but a living, interwoven whole. By daring to look differently at the simplest of phenomena, Einstein had changed everything humanity thought it knew. He had reached across the boundaries of perception and found the underlying unity of existence. And yet, this was only the beginning. The young patent clerk, who once dreamed of riding a beam of light, had taken humanity's understanding of the universe to the edge of a new dimension. What lay beyond would challenge even him. The realization that gravity itself was not what it seemed, and that the geometry of space-time held the key to the cosmic dance of creation and destruction. The revolution had begun, quietly, in the mind of one man who dared to see what others could not. The old world of absolute time and fixed space had ended. A new vision of the universe had been born. A vision in which light, time, and gravity flowed together in one cosmic harmony. When Albert Einstein published the theory of special relativity, the scientific world could scarcely grasp what had been unleashed. The shock was not only in the mathematics, but in the realization that something as familiar as time could bend, stretch, and even stop. The centuries-old pillars of certainty began to tremble, yet the full magnitude of the transformation was still to come. Einstein himself felt that his work had only opened a door. Beyond it lay a landscape so vast and strange that even he hesitated before entering. It was the realm where gravity, time, and the geometry of the universe would merge into one vision. In the years that followed 1905, Einstein's imagination refused to rest. He kept returning to the same haunting thought: if motion could affect time, what would happen near something incredibly massive, like the sun or a star? Would time itself slow down under gravity's pull? Would light, the most steadfast traveler in existence, bend as it passed by? To answer these questions, he would need to rethink gravity from its very foundations. For more than 2 centuries, Isaac Newton's theory had described gravity as an invisible force acting across space, pulling masses together. To everyone else, that explanation was complete, elegant, and final. But Einstein sensed that something deeper hid beneath it. He imagined an elevator floating in space, free from gravity. Inside, objects drifted weightless. Now he imagined that same elevator accelerating upward. Suddenly, the floor pressed against his feet, mimicking gravity itself. From this simple image, he realized a breathtaking truth: that acceleration and gravity were one and the same. The force of gravity was not a pull at all, but a consequence of motion through curved spacetime. This insight became the heart of his next creation, the general theory of relativity. It took him nearly 10 years to build it, a decade of relentless thought, endless frustration, and sleepless nights. He struggled to express his intuition in the precise language of mathematics. At times, Even he doubted he could find the equations that matched the beauty he saw in his mind. Friends recalled seeing him walking alone, lost in thought, lips moving silently as if speaking to the universe itself. Then, in late 1915, after countless revisions, the equations finally fell into place, simple yet profound. They described how mass and energy tell space how to curve, and how curved space tells matter how to move. The universe, it turned out, was not governed by distant forces, but by the geometry of its own fabric. Space was not passive, it was alive, dynamic, and responsive. When Einstein presented his results in Berlin, the audience was awestruck. Yet the true test of genius is not applause, but proof. Einstein predicted that light from distant stars would bend when passing near the sun, its path curved by the sun's gravity. The effect was tiny, less than 2 arc-seconds, but measurable. Years passed before anyone could test it. Then, in 1919, during a total solar eclipse, British astronomer Sir Arthur Eddington led an expedition to photograph stars near the darkened sun. When the plates were analyzed, the starlight had indeed shifted exactly as Einstein had predicted. That moment changed everything. Overnight, Einstein became a global icon. Newspapers declared that Newton's universe has fallen. Crowds gathered wherever he appeared. Yet, behind the fame, Einstein remained calm, almost detached. He had not sought glory, he had sought understanding. To him, the eclipse was not proof of personal success, but a confirmation that the universe truly spoke the language of relativity. The implications of general relativity were staggering. It meant that gravity could bend light, slow time, and even trap it completely inside regions so dense that nothing could escape. What we now call black holes. It predicted that the universe itself could not remain static, it must either expand or contract. At the time, these ideas sounded like science fiction. The cosmos was still imagined as eternal and unchanging. Yet, within Einstein's equations, the seeds of the Big Bang already lay hidden. Einstein's vision stretched beyond scientific boundaries. He began to see the universe as a vast, interwoven whole, a cosmic symphony in which matter, energy, and geometry played together in perfect harmony. He often spoke of a feeling of cosmic religion, not in the sense of dogma, but as awe for the rational beauty of creation. The most incomprehensible thing about the universe, he said, is that it is comprehensible. His faith was in order itself, that beneath the chaos of phenomena lay a deep and elegant simplicity waiting to be uncovered by reason. The revolution he began did not end with his lifetime. Decades later, satellites would confirm that clocks on fast, moving spacecraft tick more slowly, just as he had foreseen. Astronomers would watch starlight curve around galaxies, proving that spacetime itself bends. Even the ripples he predicted, gravitational waves, would be detected a century after he wrote the equations, tiny tremors in the cosmic fabric, caused by colliding black holes billions of light years away. Every discovery whispered the same message. Einstein had seen the truth long before the instruments could, but perhaps the most profound impact of his revolutionary thinking was not limited to physics. It transformed philosophy, art, and the human imagination. Before Einstein, reality was a stage of certainties. Afterward, it became a dance of perspectives. Painters, poets, and writers began to explore relativity in their own forms. Cubism shattered visual space into multiple viewpoints. Literature experimented with time and memory, and humanity itself began to grasp that objectivity had limits. The world had become relative, dynamic, and interconnected, just as Einstein had revealed. Through all the acclaim, Einstein remained humble. He often said that he felt like a child who, while playing on the seashore, had found a few pretty shells while the great ocean of truth lay undiscovered before him. Fame, honors, and invitations surrounded him, yet his true joy came from solitude, from losing himself in the quiet rhythm of equations or the harmony of his violin. In music and mathematics, he found the same eternal beauty, structure, symmetry, and resonance. Einstein's transformation of space and time was more than scientific. It was spiritual in its scope. He showed that the universe is not a cold mechanism, but a living continuum, where every motion, every second, every atom participates in the same grand design. Time is not a river flowing independently of us, we are the river. Space is not emptiness, it is the fabric that holds us. In his vision, past, present, and future coexist as one, different slices of a single cosmic whole. This understanding carried deep philosophical consequences. If time is relative, then simultaneity, the idea that two events happen at once, depends on the observer. There is no universal now. The universe does not experience time the way we do. Everything that has happened and will happen is part of the same space-time continuum. To Einstein, this meant that the distinction between past and future is an illusion, stubbornly persistent, but still an illusion. In this view, death itself was not the end but a shift in perspective, one thread continuing in the vast fabric of being. Such ideas transcended physics and touched the core of human thought. They reshaped how we view reality and our place within it. For Einstein, understanding the universe was an act of liberation, freeing the mind from superstition, freeing the spirit from fear. He believed that knowledge brought humility, and that humility opened the door to wisdom. His relativity was not just about motion, it was about compassion. A recognition that every perspective holds value, that truth looks different depending on where one stands. As the 20th century advanced, Einstein watched the consequences of his discoveries unfold in both awe and sorrow. His equation atomacy dives, so simple and elegant, had revealed the immense energy hidden within matter. In the hands of humanity, that knowledge became both a promise and a threat. The same principle that powered the stars also fueled the atomic bomb. Einstein, horrified by the weaponization of his ideas, became a voice for peace. He wrote letters, gave speeches, and urged nations to use science for creation, not destruction. The release of atomic power, he said, has changed everything except our way of thinking. Through all his years, Einstein never lost his sense of wonder. Even in old age, he would look up at the night sky with the same curiosity that once filled the boy holding a compass. The stars that had inspired his theories now seemed closer, more intimate. He had not conquered the cosmos. He had joined it in thought. When asked what drove him, he answered simply, "I want to know how God created this world. I am not interested in this or that phenomenon. I want to know his thoughts, the rest are details." In the decades since his death, science has continued to build upon his foundations, exploring black holes, dark energy, and the expansion of the universe. Each discovery leads back to Einstein's insight that space and time are not static but dynamic, not separate but one. Astronomers now speak of space-time rippling like water, of galaxies moving through a cosmic ocean. The images captured by modern telescopes, the bending of light, the birth of stars, the collision of worlds, are living confirmations of the vision he imagined more than a century ago. Einstein's revolution changed not only how we see the universe, but how we see ourselves. We are no longer observers standing outside creation, we are participants woven into its fabric. Every heartbeat, every step, every moment is part of the geometry of existence. The energy that burns in the stars is the same energy that glows within us. Time flows through our lives as it flows through galaxies. Relative, continuous, and sacred. In the end, Einstein's gift to humanity was more than relativity. It was perspective, a reminder that the boundaries of reality are drawn by the limits of imagination. When we dare to look beyond those limits, new worlds appear. He taught that curiosity is the true engine of progress, and that the universe rewards those who question the obvious. His thinking transformed physics, but his courage transformed the human spirit. Today, when we look at the night sky, the light we see has traveled for billions of years through the curved corridors of space-time. Each photon carries a whisper of Einstein's discovery, a message from the past that continues to shape the future. The stars bend and shimmer because of him. Our clocks tick in harmony with his equations. Our understanding of existence bears his signature. Albert Einstein's revolutionary thinking did not just change science. It changed consciousness. He revealed that reality is not a rigid cage, but a flexible tapestry woven by energy, motion, and perspective. He gave humanity a new universe, one filled with mystery, beauty, and infinite possibility. And so, the story comes full circle. The boy who once wondered why a compass needle pointed north grew into the man who showed the world that even time and space can move. His imagination tore down the walls of certainty and opened the gates to the cosmos. Albert Einstein, the genius who saw the future, taught us that the universe is not somewhere out there. It is here within us, around us, and through us, bending with every heartbeat, stretching with every thought, and unfolding endlessly in the light of curiosity. The story of relativity is not only the story of equations and experiments, it is the story of a mind that refused to accept limits. It begins with a man alone in a small patent office in Bern, Switzerland, staring at the quiet ticking of a clock and wondering what time truly means. Albert Einstein, in his mid-20s, was unknown, uncelebrated, and far from the great universities of Europe. Yet, within the stillness of that small room, the universe was beginning to change. Each day, he would sort through inventions, mechanical devices, electrical circuits, designs for machines that would never see the light of day. But his mind drifted beyond those papers. He was haunted by a single question that had followed him since childhood: what would the world look like if I rode alongside a beam of light? It was a question that no one else dared to ask. To others, light was simply light. To Einstein, it was the key to understanding the deepest laws of reality. For years, physicists believed in the existence of an invisible substance called the ether that supposedly filled all space and carried light waves, just as air carries sound. The great scientists of the time, from Maxwell to Lorentz, built their theories upon this unseen fabric. But something in Einstein's intuition told him that the ether was an illusion, a mathematical crutch that nature did not need. He began to strip away every assumption, searching for truth in its purest form. He studied the works of James Clerk Maxwell, whose equations described the behavior of light and electromagnetism. Those equations stated that light always moves at a constant speed, 299,792 kilometers per second, no matter how fast the source or the observer moves. But this was a paradox. If one train moves toward another, their relative speeds add up, yet light did not behave this way. Its speed never changed. To most physicists, this contradiction was troubling. To Einstein, it was an invitation. He began to imagine thought experiments, mental journeys that replaced laboratories with imagination. In one, he pictured himself on a train moving near the speed of light. If he shined a flashlight forward, would the beam move away from him at the same speed, or would it appear frozen? The answer, according to classical physics, was unclear. But Einstein saw something profound: the laws of nature must look the same to all observers, no matter their motion. Time, therefore, could not be absolute. Space could not be fixed. They had to adjust themselves so that light's speed remained constant for everyone. This simple yet radical idea shattered the foundations of classical physics. The universe was not a rigid stage upon which events unfolded. It was flexible, dynamic, alive. Space and time were no longer separate, they were woven together into a single continuum, space-time. In 1905, after years of silent thought, Einstein wrote a paper titled On the Electrodynamics of Moving Bodies. It was just 30 pages long, but it contained the seeds of a revolution. Within its pages, he presented what would come to be known as the special theory of relativity. He declared that time and space are relative to the observer's motion, and that only the speed of light remains constant. To preserve this universal speed, time must slow down for fast, moving objects, and their lengths must contract. What seemed like science fiction was, in truth, the nature of reality itself. He later added a short, brilliant note to the theory, one that introduced the world to a new law of nature, idem esse die. With those 5 characters, he united energy and mass into one essence. Matter, it turned out, was frozen energy, and energy could become matter. The universe, in Einstein's view, was an endless dance between the two. At first, the world paid little attention. The paper was dense, mathematical, and so far ahead of its time that even leading physicists struggled to understand it. Einstein continued his quiet life at the patent office, riding his bicycle through Bern's cobbled streets, playing his violin in the evenings. Yet beneath that modest exterior, the structure of the cosmos had already changed forever. Gradually, his ideas began to reach the scientific community. Some resisted, unable to accept that time could slow down or that simultaneity could vanish. Others, like Max Planck, the father of quantum theory, recognized the genius immediately. Planck wrote to Einstein, calling his work one of the most remarkable achievements in the history of human thought. The years that followed saw the world begin to test and grasp the meaning of relativity. Experiments with fast-moving particles confirmed that time truly dilated as Einstein had predicted. Clocks on airplanes and satellites began to show measurable differences, matching his equations with astonishing precision. What had once been theory became reality. But Einstein was not driven by fame or validation. He was driven by wonder, the pure joy of knowing. He said, "I have no special talent. I am only passionately curious." To him, physics was not about power or progress, it was about harmony, finding the symphony that nature played beneath all appearances. As the 20th century unfolded, Einstein's theory began to shape every corner of science. The concept of relativity did not simply refine physics, it redefined it. Energy and matter, once separate, became unified. The boundaries between past, present, and future blurred. Even the fabric of the universe gained a new identity, one that bends, stretches, and evolves with motion and mass. This new vision of reality changed how humanity saw everything, from the smallest atoms to the largest galaxies. In laboratories, scientists began exploring the implications of Einstein's equation, discovering that even tiny particles contained immense energy. The atom, once thought indivisible, became a source of cosmic power. Nuclear science, radiation, and modern particle physics all grew from the roots Einstein had planted. Yet his discoveries also carried moral weight. When asked how he felt about the equation E=mc leading to nuclear weapons, Einstein sighed deeply and said, "If only I had known, I would have become a watchmaker." His vision was meant for enlightenment, not destruction. He had revealed nature's secret power, but it was humanity's responsibility to use it wisely. Einstein's theory also inspired the next generation of scientists to explore the quantum world. Though he himself struggled with some of its interpretations, his work opened the doors to quantum mechanics, cosmology, and the search for a unified theory, a single framework to explain everything. He dreamed of this theory of everything until his final days, searching for harmony between the infinitely large and the infinitely small. But beyond the science, relativity had a profound philosophical impact. It shattered the idea of absolutes, not only in physics but in perception, art, and thought. If time and space themselves were relative, then so too were our experiences, our perspectives, and our understanding of truth. The age of certainty ended, the age of relativity began. Painters like Picasso began experimenting with multiple perspectives, writers like Proust explored the fluidity of memory and time, and philosophers reconsidered the nature of reality itself. In classrooms and lecture halls, the name Einstein became synonymous with genius, not because he knew everything, but because he dared to imagine differently. His work taught that progress does not come from obedience, but from curiosity. He showed that even the most familiar truths could be illusions when viewed from a new frame of reference. Relativity's impact reached far beyond academia. Without it, the modern world would look completely different. The synchronization of GPS satellites, the understanding of cosmic expansion, the operation of nuclear reactors, and even the bending of starlight, all depend on Einstein's equations. Every smartphone that calculates location, every telescope that maps distant galaxies, every spacecraft that navigates through space, all whisper the silent truth of relativity. And yet, Einstein's journey toward creating this theory was not easy. He faced isolation, skepticism, and poverty. Few believed in his ideas when he began. He had no laboratory, no university support, no research grants, only thought, patience, and a pen. It was perhaps one of the greatest intellectual acts ever performed by a single human being, to rethink the universe from a quiet desk. He would later describe the feeling of discovery not as triumph, but as serenity, like glimpsing a hidden order behind the chaos of existence. For him, relativity was not an invention, it was a revelation. "I did not arrive at my conclusions through rational thinking," he once said, "but through intuition and a deep faith in the simplicity of nature." The creation of the theory of relativity stands as a monument to human imagination. It reminds us that truth is not found by following footsteps, but by daring to wander where there are no paths. Einstein did not merely solve a scientific problem, he rewrote the story of reality. By 1915, as he extended his ideas into the general theory of relativity, the transformation became complete. Gravity was no longer a force, it was the curvature of spacetime itself. The Earth does not orbit the Sun because of an invisible pull. It moves along the curves of spacetime created by the Sun's mass. The universe, at last, had become a living, flexible entity. From the small patent office in Bern to the observatories of the world, Einstein's journey was not one of fame, but of vision. He had seen what no one else could, a universe where space and time are not separate threads, but one woven fabric, bending under the weight of creation. The birth of relativity was not the triumph of mathematics alone, it was the triumph of imagination. It showed humanity that the boundaries of the possible are written not in nature, but in thought. Einstein's mind had reached across the horizon of understanding and touched the infinite. His discovery was not an ending but a beginning, the dawn of a new way to see reality. The world would never look the same again. When the echoes of Einstein's equations first reached the world, the reaction was disbelief mixed with wonder. Mathematicians checked and re-checked the numbers, astronomers re-examined their measurements, and philosophers wrestled with the meaning of a universe that no longer obeyed the reassuring rules of common sense. Yet, as each test confirmed his predictions, resistance gave way to awe. Humanity realized that the cosmos was far stranger and far more beautiful than it had ever dared to imagine. Relativity did not remain confined to the chalkboards of physicists. It seeped quietly into the fabric of daily life, often invisible, always essential. Every global positioning satellite orbiting high above the Earth must correct its clocks for both special and general relativistic effects. Moving fast slows time and weaker gravity makes it run faster. Without those adjustments, amounting to billionths of a second, the navigation on every ship, plane, and phone would drift miles off course each day. The same equations that once existed only in Einstein's mind now guide travelers, rescue teams, and explorers across the planet. In astronomy, relativity became the lens through which the universe revealed itself. The bending of light around massive bodies, once a theoretical curiosity, turned out to be a powerful tool. It allowed scientists to detect distant galaxies magnified by the gravity of clusters between them, a phenomenon now called gravitational lensing. Telescopes like the Hubble and the James Webb capture these cosmic mirages, each one a silent tribute to the young clerk from Bern who dared to imagine that light could curve. Relativity also gave birth to modern cosmology. When Einstein first applied his equations to the entire universe, he was startled by the result: the cosmos could not remain static. It must expand or contract. Troubled by this implication, he inserted a cosmological constant into his formulas to hold the universe steady. Years later, when Edwin Hubble observed that galaxies were indeed rushing away from one another, Einstein admitted that removing the constant had been the greater truth. "That was my biggest blunder," he said, though the so-called blunder would return a century later when scientists discovered dark energy accelerating that same expansion. Even Einstein's discarded ideas carried seeds for the future. The impact of relativity on theoretical physics was revolutionary. It united space and time into spacetime, matter and energy into a single continuum, and motion and gravity into geometry. This new picture demanded a new language. Physicists began describing the universe not in straight lines and simple forces, but in curved metrics and tensors. To map the cosmos now meant to map its curvature. Stars, planets, and light itself followed paths called geodesics, the natural trajectories within the warped structure of existence. At the smallest scales, relativity also began to shape quantum theory. When scientists such as Dirac tried to combine Einstein's framework with the strange behavior of subatomic particles, they discovered entirely new phenomena: antimatter, spin, and quantum fields. Particle accelerators, built decades later, would confirm these predictions, turning Einstein's vision into the foundation of the standard model of physics. Even though he himself struggled to accept quantum uncertainty, his relativity became the stage upon which quantum mechanics performed. The reach of Einstein's insight extended to the star's final moments. Astrophysicists realized that when a massive star collapses under its own gravity, spacetime can curve so sharply that not even light can escape. The birth of a black hole. For decades, these objects remained theoretical phantoms, but observations have now caught their shadows. The Event Horizon Telescope's first image of a black hole's glowing ring was not just an astronomical triumph. It was a living photograph of Einstein's mathematics, drawn in the light of a dying galaxy. Gravitational waves were another whisper of his genius. In 1916, he predicted that when massive bodies move violently, they send ripples through spacetime itself. 100 years later, LIGO's detectors heard that faint tremor from two merging black holes, a vibration so small it stretched the Earth by less than a fraction of a proton's width. The sound, converted into an audible tone, was a cosmic heartbeat echoing from billions of light years away. Einstein had foreseen it before the technology to measure it existed. Relativity also transformed time itself into a scientific instrument. Atomic clocks aboard satellites and in laboratories measure temporal shifts caused by altitude and motion with extraordinary precision. These effects confirm, again and again, that time flows differently depending on where you stand and how fast you move. The absolute time, once imagined by Newton, has vanished. In its place lies a living fabric where every observer carries a personal rhythm of the cosmos. Yet the revolution was not purely technical. It changed humanity's philosophy. The idea that everything, including perception, is relative to the observer resonated far beyond physics. Artists, writers, and thinkers seized on it. The Cubists fractured perspective on canvas, reflecting the relativity of sight. Novelists like Virginia Woolf and James Joyce played with time's elasticity in narrative, turning memory into motion. The modernist movement itself pulsed with Einstein's influence. Culture began to mirror the flexible universe he described. Einstein's theory even touched religion and metaphysics. Many saw in his equations a glimpse of divine order, an elegant, mathematical language through which creation speaks. Einstein himself resisted labels. He did not believe in a personal God, but often spoke of a cosmic religion, a deep awe for the rational harmony of nature. To him, every discovery was an act of reverence. Understanding the laws of the universe meant, in some sense, participating in its creation. Despite his growing fame, Einstein remained humble. When crowds pressed around him, he joked, "In the past, it was the Pope who carried the burden of infallibility. Now it seems to be mine." He preferred solitude, sailing or playing the violin, his thoughts drifting back to equations and patterns. Fame was an accident, curiosity was the constant. Relativity's practical offspring continued to multiply. Nuclear energy, though controversial, derived from the equivalence of mass and energy. Particle accelerators, medical imaging, and even the understanding of solar fusion all trace their lineage to Etum and Ceti. The same formula that governs the life of stars powers the devices that scan human hearts. It linked the cosmic and the personal, the infinite and the intimate. The deeper scientists looked into Einstein's ideas, the more interconnected reality appeared. Space, time, matter, and energy were not separate ingredients but aspects of one grand field. Later physicists, inspired by this unity, pursued the dream of combining relativity with quantum mechanics, a quest still ongoing in string theory and loop quantum gravity. Each attempt is an echo of Einstein's final wish to see the universe not as many laws but as one. Relativity also reshaped the story of creation itself. The Big Bang model, born from his equations, described a universe that began as a single, incomprehensibly dense point and has been expanding ever since. Modern cosmology's measurements of background radiation, dark matter, and cosmic inflation all spring from this foundation. Einstein had shown that space and time could have an origin, a birth, and perhaps one day an end. The eternal cosmos had become a living, evolving being. For scientists and dreamers alike, this realization carried profound emotional weight. The universe was not a static clockwork mechanism but a cosmic organism, breathing, expanding, and changing. Humanity was no longer a mere spectator but part of the same unfolding story. Every atom in the human body was forged in the furnace of stars, whose behavior followed Einstein's laws. To understand relativity was to understand one's own ancestry on a cosmic scale. Even now researchers test the limits of his theory. They send spacecraft to measure time dilation near other planets, track pulsars orbiting invisible companions, and study gravitational lensing from galaxies billions of light-years away. Each experiment, so far, affirms his equations. Yet Einstein himself would have welcomed their challenge. He believed that no idea, not even his own, should become sacred. Science, he said, must remain forever young, questioning, self-correcting, alive. Beyond laboratories, relativity influenced how societies thought about knowledge and truth. The notion that observation shapes reality encouraged humility. Our understanding is always partial, dependent on perspective. It fostered a culture of dialogue in science, an acknowledgement that progress arises from the interplay of many viewpoints. In this sense, Einstein's physics became an ethical model. Reality is richer when seen through multiple frames. The impact also reached technology's frontier. Satellite communication, space exploration, and high-energy astrophysics all rely on relativistic corrections. Without them, probes could not slingshot accurately around planets, and images from deep space would distort. Even the possibility of interstellar travel, still a dream, is defined by relativistic limits. The closer one approaches light speed, the more time stretches, the more the traveler steps toward the future. Einstein's equations set both the boundaries and the hope of cosmic journeying. In education, relativity transformed how physics was taught. Students no longer memorized isolated formulas, they learned to see connections. The universe became a geometry, not a machine. Space and time curved under thought itself. Teachers used Einstein's story to show that genius is not about privilege, but about persistence. The courage to think differently even when alone. And still, amid all the consequences, technological, philosophical, cultural, there remains something profoundly human in Einstein's revolution. At its heart lies a simple act: the refusal to stop asking questions. The young man who wondered about riding a beam of light never stopped wondering. His curiosity became humanity's compass. It guided us from the visible to the invisible, from the certainty of clocks to the fluidity of time itself. Today, every photograph of a warped galaxy, every signal from a distant pulsar, every gravitational wave detection is part of his continuing legacy. They are modern chapters of the story he began in 1905. The equations he scribbled in solitude have become the architecture of reality. Einstein's creation of relativity was more than a scientific triumph. It was a declaration of intellectual freedom. It told the world that truth is not inherited but discovered, that imagination is not fantasy but a tool of revelation. He showed that one mind, guided by curiosity and integrity, could rewrite the cosmos. As the 20th century closed and the 21st began, relativity remained the cornerstone of all advanced physics. Its influence stretches from the behavior of subatomic particles to the fate of galaxies. It underpins technologies that orbit Earth and theories that explore the edge of time. It continues to evolve just as the universe does. And somewhere in that evolution, Einstein's spirit endures. The quiet smile, the wild hair, the eyes that seemed always to be looking just beyond the horizon. He once said, "The important thing is not to stop questioning. Curiosity has its own reason for existing. That reason lives on in every experiment, every telescope, every child who looks at the night sky and wonders." The theory of relativity did more than change science, it changed the human story. It taught us that our reality is fluid, interconnected, and vast beyond measure. It invited us to see ourselves not as masters of nature, but as participants in its unfolding. It reminded us that the universe is not static. It is alive, evolving, and filled with endless mystery. And so, the journey continues. The equations, written in that small patent office, have become the language of the stars. The light that bends through galaxies carries his signature. The time that flows through every heartbeat bears his rhythm. In the grand symphony of the cosmos, Albert Einstein's melody still plays, a quiet, eternal reminder that imagination can see the future, and in seeing it, reshape the world. The dawn of the 20th century was an era of turmoil and transformation. The world was standing between the old and the new. Science was stretching beyond the limits of classical thought, and humanity was stepping into the age of energy, motion, and light. In this unfolding world, Albert Einstein emerged as a figure who could see what others could not. He could see the invisible threads connecting the cosmos, the delicate harmony between matter, energy, and time. The fourth keynote of his journey lies in the revelation of his greatest idea, the theory of relativity, a discovery that did not merely change physics, but altered the way we understand reality itself. It was not born in grand laboratories or amidst teams of researchers. It was born in silence, in imagination, in the mind of one man who dared to ask, "What is time?" Einstein's relativity was not just a theory, it was a revolution. It began with a simple thought: what would the world look like if one could ride alongside a beam of light? In that question lay the seed of a new universe. For centuries, Newton's laws had ruled science with certainty and precision, describing the world as predictable, mechanical, and absolute. Time was seen as a universal clock, ticking the same everywhere, and space as a fixed stage upon which matter moved. But Einstein's imagination shattered this illusion. He proposed that time was not absolute. It bent, stretched, and flowed depending on the speed at which one moved. Space, too, was not rigid, it curved around mass and energy. The universe was no longer a silent machine, but a living fabric woven together by motion and gravity. In 1905, while working in the Swiss Patent Office, Einstein published 4 papers that would become known as the Annus Mirabilis, the miraculous year. Among them was the special theory of relativity, the cornerstone of modern physics. With a single equation, E mc div, he showed that mass and energy were 2 sides of the same coin, interchangeable and unified. This idea became the foundation of nuclear energy, the understanding of stars, and the very mechanics of the cosmos. Yet, when Einstein first proposed it, few believed him. The equations were too strange, the implications too vast. The idea that time could slow down, that space could bend, or that energy could become matter defied all intuition. But Einstein stood firm, guided not by acceptance but by truth. The beauty of relativity was not only in its mathematics but in its vision. Einstein saw the universe not as separate pieces of matter, but as one connected whole, where the motion of a planet and the ticking of a clock were governed by the same laws. His imagination pierced through the veil of reality, revealing a deeper unity beneath all things. It was as though he had opened a window into the structure of existence itself. This was why people called him the genius who saw the future, because his theories described things that human eyes could not yet see. Years later, Einstein expanded his ideas into the general theory of relativity, which described gravity not as a force but as the curvature of space, time caused by mass and energy. It explained the motion of planets, the bending of light near stars, and even predicted black holes, regions so dense that not even light could escape. When, in 1919, British astronomer Arthur Eddington observed the bending of starlight during a solar eclipse, Einstein's theory was confirmed. Overnight, he became a global legend. Newspapers declared that Newton's throne had been replaced. Humanity had entered a new era of understanding, guided by the mind of one man who had looked beyond the limits of human perception. Yet, behind this monumental discovery was a soul driven by humility and wonder. Einstein did not see himself as a conqueror of nature, but as a servant of truth. He often said that the most beautiful experience one can have is the mysterious, for it is the source of all true art and science. His relativity was not an act of ego but of curiosity, a quest to see reality as it truly is, not as we wish it to be. He was not seeking fame or glory, he was seeking the truth of the cosmos. The impact of relativity rippled far beyond physics. It transformed philosophy, art, and even human consciousness. Time and space were no longer constants, but relative experiences, tied to the observer. The universe became dynamic, alive, and interconnected. Even decades later, as scientists observed the expansion of the cosmos, gravitational waves, and the birth of stars, they continued to find Einstein's fingerprints on every discovery. His equations became the language of the universe, elegant, eternal, and universal. But perhaps the most profound legacy of Einstein's theory lies not in its complexity, but in its simplicity, in the way it reminds us that everything in existence is connected. Mass becomes energy, energy becomes light, and light travels through the curvature of space, time, carrying with it the story of the universe. In Einstein's vision, science and philosophy merged into one. The cosmos was no longer distant and mechanical, it was intimate, alive, and full of meaning. Through relativity, Einstein gave humanity a new way to see reality, not as static, but as fluid and infinite. He revealed that truth itself is relative to perspective, and yet, through understanding, we can find unity in diversity. The man who once struggled in classrooms had become the architect of modern thought. He had turned imagination into law, and dreams into equations that could measure the heartbeat of stars. The theory of relativity was not just the triumph of a scientist, it was the triumph of human curiosity. It proved that even one mind, guided by wonder, could reshape the destiny of the world. The years that followed Einstein's rise to fame were filled with both glory and burden. The man who once lived in obscurity was now the most recognized scientist on Earth. Yet, behind the flashes of cameras and the roar of applause stood a man who never sought fame, only understanding. The fifth keynote in Einstein's journey is not about equations or discoveries, but about his vision for humanity. His moral compass, his courage to speak truth, and his belief that science without conscience was empty. As his theories reshaped the physical world, Einstein began to focus on reshaping the human spirit. He lived in a time of global upheaval, when the world was teetering between progress and destruction. The same discoveries that unlocked the secrets of energy also gave birth to new weapons of unimaginable power. Einstein, whose equation E = mc diode had revealed the connection between mass and energy, found himself haunted by its darker potential. As nations raced toward militarization, he feared that his work might one day be used to bring devastation instead of enlightenment. When World War II erupted, those fears became reality. Scientists harnessed nuclear energy not for creation, but for destruction. Though Einstein did not directly work on the atomic bomb, his famous letter to President Franklin D. Roosevelt in 1939, warning that Nazi Germany might be developing such a weapon, played a role in the birth of the Manhattan Project. Later, he would call that letter his greatest regret. Einstein was not a man of war, he was a man of peace. His conscience could not rest knowing that science had become a tool of violence. He began to use his voice not as a physicist, but as a philosopher and humanitarian. He spoke out against nationalism, against hatred, against the blind obedience that led men to destroy one another. For him, the pursuit of knowledge was sacred, but only if it served humanity. He once said, "Peace cannot be kept by force, it can only be achieved by understanding." Those words reflected the heart of his philosophy, that reason and compassion must walk together if civilization is to survive. In the years after the war, Einstein became one of the world's most powerful advocates for peace. He joined efforts to prevent nuclear proliferation and urged the establishment of a global government that could protect humanity from self-destruction. To many, his ideas seemed utopian, but to Einstein they were essential. He believed that human survival depended on unity, that science had proven how interconnected everything was, and now humanity must live by that truth. Just as space and time were woven together, so too were all people, all nations, all destinies. Yet, his advocacy was not limited to global issues. In America, where he spent his final decades, Einstein witnessed racism and inequality with deep sadness. He spoke openly against segregation, calling it a disease of white people. He supported civil rights leaders like W.E.B. Du Bois and Paul Robeson and used his fame to draw attention to the injustices faced by Black Americans. For him, equality was not a political matter but a moral one, a test of humanity's wisdom and compassion. Einstein's spiritual beliefs also reflected his humanistic outlook. He did not follow organized religion, yet he often spoke of a cosmic religious feeling, a sense of awe at the order and mystery of the universe. He believed that behind the laws of physics lay something profound and beautiful, something that united all existence. "The most incomprehensible thing about the universe," he once said, "is that it is comprehensible." To him, understanding nature was not just an act of intellect, but a form of reverence. He saw science and spirituality not as enemies, but as partners in the search for truth. As his fame grew, Einstein refused to live like a celebrity. He wore the same clothes, rejected luxury, and spent his days in quiet reflection. Reporters were fascinated by his simplicity, his humor, and his humility. He once said, "I have no special talents. I am only passionately curious." Those words captured the essence of who he was, not a prophet or magician, but a seeker. His power came not from ambition, but from sincerity. Even when honored by kings and presidents, Einstein remained the same, a man devoted to truth and kindness. In his later years, Einstein continued to warn of the dangers of blind technology and moral decay. He feared that humanity's intelligence was growing faster than its wisdom. "The splitting of the atom has changed everything," he said, "except our way of thinking." For him, the real revolution must happen not in laboratories, but in hearts and minds. He urged young people to question authority, to think for themselves, and to build a world guided by compassion rather than power. As he neared the end of his life, Einstein became a symbol of the harmony between intellect and morality. He had seen the best and worst of humanity, the brilliance of discovery and the horror of war. Through it all, he remained faithful to his belief that goodness, truth, and love were the highest forms of intelligence. His message to the world was simple yet eternal: knowledge must serve life, not destroy it. When Albert Einstein passed away in 1955, the world mourned not just the loss of a genius, but of a voice of conscience. His brain was studied, his theories immortalized, but his greatest legacy lived in his ideals, in the belief that imagination, empathy, and courage could light the path toward a better future. Einstein had seen the future not only through equations, but through compassion. And that is why, even today, his name does not just stand for intelligence, it stands for wisdom. As the 20th century unfolded, the name Albert Einstein became more than that of a scientist, it became a symbol of human genius itself. But the sixth keynote in his journey tells a story deeper than intellect. It is the story of how one man's ideas redefined humanity's place in the cosmos. After his revolutionary theories had shaken the world, Einstein's vision expanded beyond equations and laboratories. He began to see the universe as a grand symphony, where every particle, every star, every life was part of an eternal melody of existence. His scientific work had shown that reality was interconnected, that space and time were not separate but one continuous fabric. Yet what made Einstein extraordinary was his ability to translate this cosmic vision into human meaning. He did not see himself as a ruler of knowledge, but as a witness to the beauty of the unknown. Einstein's later years were filled with reflection on science, philosophy, and the destiny of humankind. He often said that the deeper he looked into the universe, the more he felt a sense of humility. The eternal mystery of the world, he wrote, is its comprehensibility. To him, understanding nature was not merely about logic or mathematics, it was about aligning oneself with the profound order of creation. Every equation, every theory was a bridge between the human mind and the cosmic truth that lay beyond human senses. His belief in the unity of all things became the foundation of his worldview. Whether it was light, gravity, or consciousness, he saw everything as connected by invisible laws of harmony. As science advanced, Einstein continued to seek a single framework that could unite all forces of nature, what he called a unified field theory. It was an attempt to describe the entire universe in one elegant equation. Although he never completed it, this pursuit consumed his final decades. Day after day, he worked alone in his study at Princeton, surrounded by notes, chalkboards, and the quiet hum of curiosity. He knew he might never find the answer, but the search itself gave meaning to his life. He believed that the ultimate purpose of science was not mastery, but wonder, not to control nature, but to understand its divine rhythm. Even when younger scientists moved on to new ideas like quantum mechanics, which Einstein famously resisted, he remained steadfast in his conviction that the universe was not ruled by chance. God does not play dice with the universe, he declared, not as a statement of religion, but of faith in order and reason. His debates with Niels Bohr over quantum theory became legendary, two giants of physics standing at opposite ends of a philosophical divide. Bohr saw uncertainty as a fundamental law of nature, while Einstein sought deeper, hidden rules beneath the chaos. Though history would favor quantum theory, Einstein's persistence symbolized his eternal belief in harmony. He was not fighting against science but against the idea that randomness defined existence. For him, every law of physics was a sign of structure, a hint of purpose in the cosmic design. Even when his ideas were dismissed by younger physicists, he bore no bitterness. He often smiled and said that time would tell, and indeed, decades later, many of his intuitions would find echoes in modern theories of space, time, and cosmology. Einstein's fascination with the stars never faded. He often walked at night, looking up at the sky, thinking about the vastness of it all, galaxies drifting through time, light traveling across billions of years, the whisper of creation still echoing in the fabric of space. He once said, "The most beautiful experience we can have is the mysterious." This sentence captured the essence of his soul. He lived not for certainty, but for the thrill of discovering what lies beyond it. For Einstein, mystery was not something to fear, it was something sacred. It connected humanity to the infinite. In his later writings, Einstein began to merge science with a quiet spirituality. He rejected organized religion, but believed deeply in what he called the cosmic religious feeling, a reverence for the rational order of the universe. He saw science as an act of faith, not faith in gods or dogmas, but faith in the intelligibility of creation. This belief gave him peace in a world shaken by wars, politics, and division. While the world admired his intellect, Einstein himself admired simplicity, kindness, and moral courage far more than brilliance. He often said that a life guided by compassion and curiosity was the truest expression of wisdom. As he grew older, his hair turned whiter, his steps slower, but his eyes still burned with the same light of curiosity that once shone in the child who stared at a compass needle. He continued to correspond with scientists, students, and leaders around the world, always encouraging them to think freely and never stop questioning. Even as his body weakened, his mind roamed freely through the stars. When asked near the end of his life if he still sought the ultimate theory of the universe, he smiled and replied, I want to know how God created this world. I am not interested in this or that phenomenon. I want to know his thoughts. The rest are details." In those words lay the essence of Einstein's sixth keynote, his ultimate vision of the universe. He did not see science as a collection of facts, but as a journey toward understanding the divine logic of reality. His search for unity, both scientific and spiritual, was a reflection of humanity's eternal quest to find meaning in existence. Even when he knew he might never find the final answer, he never stopped searching, because for Einstein, the journey itself was the reward. His theories gave humanity a new map of the cosmos, but his philosophy gave it something even greater: the courage to wonder. When he died in 1955, his body returned to dust, but his mind became immortal. His ideas continued to shape generations, his vision continued to guide science, and his humility continued to inspire all who seek truth. Einstein's life reminds us that genius is not only about knowing, it is about feeling, about standing in awe before the mystery of the universe. He was not just a man of numbers, he was a poet of reality, a dreamer who turned imagination into understanding. Through him, humanity learned that the universe is not a distant machine, but a living miracle. One that invites us, even now, to keep asking questions and to keep seeing beyond the stars. As the story of Albert Einstein draws to its final chapter, the seventh keynote captures the essence of his eternal legacy: the transformation of a single human mind into a timeless symbol of wisdom, imagination, and moral courage. By the time Einstein reached the twilight of his life, he had already altered the course of human history. His theories had unlocked the secrets of energy, space, and time. His words had inspired generations to seek truth and peace. Yet, beyond the mathematics, beyond the fame, Einstein's greatest contribution was the light he brought to human thought, a light that continues to guide the world long after his passing. He was more than a scientist, he was a philosopher of the cosmos, a dreamer who bridged the gap between reason and wonder. In his final years at Princeton, Einstein lived simply, quietly, and with a sense of contentment that came from a lifetime of seeking truth. He refused wealth, titles, and political positions, preferring solitude to ceremony. His office was modest, papers scattered on the desk, chalkboards filled with equations, a violin resting in the corner. He spent his mornings thinking, his afternoons walking, and his evenings reading or playing music. The same man who had revolutionized science now found joy in silence. Yet, even in those moments of peace, his mind never stopped wandering through the mysteries of the universe. The world around him was rapidly changing. The atomic age had dawned, nations were racing toward space, and technology was advancing faster than morality. Einstein watched these developments with a mix of pride and concern. He had shown humanity how to split the atom, but he feared that mankind had not yet learned how to control its own power. He became, in his last years, a voice of conscience in a world intoxicated by progress. "Our technology has surpassed our humanity," he warned, "and that is a dangerous imbalance." His words were not those of an old man resisting change, but of a visionary who saw too clearly. He understood that the same intellect capable of building rockets and bombs must also be capable of compassion, or civilization would destroy itself. To Einstein, progress meant nothing if it did not elevate the human spirit. He believed that science and ethics were not separate realms but two halves of the same truth. "Knowledge without wisdom," he said, "was like light without warmth. It could illuminate, but it could not give life." Even as his body weakened, his mind remained sharp and full of curiosity. He continued to work on his unfinished quest for a unified field theory, the dream of expressing all the forces of nature in one equation. Though he never succeeded, he accepted it gracefully, knowing that the universe was infinite and that every discovery was only a doorway to deeper mysteries. He once said, "The more I learn, the more I realize how much I don't know." Those words captured his humility and his faith in the endlessness of human exploration. Einstein never saw knowledge as a possession, he saw it as a path. His genius was not in claiming answers, but in asking the right questions, the kind that awaken wonder in others. In his final moments, as life quietly slipped away on April 18, 1955, Einstein remained at peace. He refused surgery, saying that it was tasteless to prolong life artificially. "I have done my share, it is time to go," he told his doctor. Even death, to him, was not an end but a transformation. Another mystery to be understood. His ashes were scattered in the Delaware River, as he wished, leaving no grave, no monument, only his ideas to speak for him. But in truth, Einstein did not die. His legacy continued to live in every corner of modern science, in the bending of light around galaxies, in the expansion of the cosmos, in the energy that fuels stars and powers the world. Every time humanity looks deeper into the universe, it looks through the lens Einstein gave it. What made him immortal, however, was not only his scientific brilliance but his moral vision. He believed that imagination was humanity's greatest power, the force that could shape the future. He often said, "Imagination is more important than knowledge, for knowledge is limited, but imagination encircles the world." These words became a beacon for dreamers, artists, and scientists alike. Einstein reminded the world that progress begins not with certainty but with curiosity, not with rules, but with dreams. His life proved that the mind, when guided by compassion and courage, could reshape reality itself. Einstein's story continues to echo across time because it reflects the story of humanity's own search for meaning. He showed that genius is not about perfection, but about persistence, the willingness to question everything, to fail, and to try again. He transformed solitude into discovery, doubt into vision, and equations into poetry. The child who once wondered about a compass needle ended up giving humanity a new map of existence. His theories revealed that time and space are fluid, but his spirit proved that truth and curiosity are eternal. Today, his face, with its wild hair and thoughtful eyes, is recognized everywhere, a universal symbol of intellect and integrity. But the true Einstein lives not in his portraits or statues. He lives in every spark of curiosity that drives humanity forward. Every student who dares to question, every thinker who seeks deeper truth, carries a piece of his legacy. His life reminds us that the boundaries of knowledge are not walls but horizons, meant to be crossed. Albert Einstein, the genius who saw the future, left behind more than science. He left behind a way of seeing. He taught the world that the universe is not something distant to be conquered, but something intimate to be understood. He showed that imagination could bridge the gap between what is known and what is possible. And above all, he proved that one mind, illuminated by wonder, could change the destiny of the world. His equations may describe the cosmos, but his vision describes humanity, fragile, brilliant, endlessly curious, and forever reaching for the stars.